Hello students, today I am going to explain the most important trick for SN1 and SN2 reactions. This topic is from Haloalkanes and Haloarenes chapter. Before starting this topic, let me tell you some basic concepts. In a reaction, reactant converts into product, and reactants comprises of two things. One is substrate and another is reagent. Substrate and reagent both react to form intermediate, then form product. Okay, and substrate and reagent are dissolved in a solvent and they form intermediate, then they form product. And intermediate are of three types: carbocation, carbanion, and free radical. Intermediates are of three types: carbocation, carbanion, and free radical. Now substrate, reagent, they form intermediate, then product. So substrate are again, what is substrate? Substrate, the substance which is attacked by reagent. Substrate, which is the substance which is attacked by a reagent. Now what is reagent? Reagent is a substance which attack on substrate. Reagent are of two types. One is electrophile, another is nucleophile. Electrophile is electron deficient species and nucleophile are electron rich species which donates a pair of electron, or they may have negative charge, or they may be neutral species. Example, H2O. H2O have two lone pairs. OH minus, it has negative charge. Cn minus, it has negative charge. NH3, it has lone pair. So nucleophile is a species which donates a pair of electron or which may have negative charge also. So in this chapter, nucleophiles are important for us, and here we have to discuss solvent also. So types of solvent are, there are two types of solvents: polar solvent and non-polar solvent. Polar solvent, the substance in which atoms have difference in their electronegativity. They are of two types: polar solvent and non-polar solvent. Polar and non-polar. In polar solvent further of two types: polar protic and polar aprotic. Polar protic solvents symbolizes PP and polar aprotic PA. Polar protic solvents are example H2O, which has two lone pair, one is here, one is here, and alcohol, which have again two lone pair, acetic acid, which have, and they produce H plus ions when dissolved in solution. Like alcohol, it breaks in this form, it gives H plus ions. Acetic acid, it also gives H plus ion. So it is polar protic, polar protic, polar protic, polar protic solvents. Polar aprotic solvents, they do not give H plus ions, such as acetone. This is acetone. It does not give H plus ion, because H plus ion, when it dissolves in water, H plus ions cannot be removed because it is not ionizable. Dimethyl sulfonamide, its short form is DMS. So DMS is polar aprotic solvent, example DMS. Polar protic solvent, example H2O, alcohol, and acetic acid. Now coming to non-polar solvent, the solvent in which atoms do not have difference in electronegativity. Here in N-hexane, 6 carbon are there, and there is no difference between carbon and carbon. So this is non-polar solvent. There is no difference between electronegativity. Or N-hexane, simple hexane, It is also non-polar solvent. In the solvent, substrate and reagent are dissolved in solvent. They form intermediate. 3 types of intermediate may be formed, and then product. Now we shall discuss SN1 and SN2. So first we are going to take SN1 reaction. S stands for substitution, N stands for nucleophilic, and 1 stands for its order. Order is experimentally determined. So S for substitution, N for nucleophilic, means N represent type of reagent. Here we are discussing 2 things, substrate and reagent. So if reagent is a nucleophile, then if reagent is a nucleophile, then this type of reaction is nucleophilic, and one atom substitute another, so its name is substitution. In any general reaction there is substrate, reagent. So reagent, in this case we have to take nucleophile. This suppose that this one is a substrate Rx. Here carbon is having 4 valency, 1, 2, 3 and 4, and X is an halogen atom. X may be fluorine, chlorine, bromine, iodine, anyone. Okay, now fluorine, chlorine, bromine and iodine have 2 to 4 to 6 electrons. They have 7 electrons, 1 is bonded, and 1, 2, 3, 3 are in presence of lone pair. So halogen atoms are more electronegative as compared to carbon. So halogen will withdraw these 2 electrons towards itself and get partial negative charge, and carbon will get partial positive charge. If carbon is having partial positive charge, nucleophile is having negative charge, this nucleophile will attack on the positively charged carbon, because opposite charges attract each other, and this halogen atom will be removed or substituted by the nucleophile. So this reaction is called nucleophilic substitution, because substitution is taking place and reagent is nucleophile, so name is nucleophilic substitution reaction. Now we are taking SN1 reaction, unimolecular nucleophilic substitution. Unimolecular means here one molecule is responsible for rate of reaction, only one molecule. Suppose we take the example, here one carbon is bonded with 4 types of groups, R, H, R, or these may be same or these groups may be different, and one is halogen atom. Now what will happen? This type of reaction is take place by weak nucleophile. This nucleophile should be weaker. Now this halogen atom is more electronegative, so this halogen atom will withdraw these or take these 2 electrons and breaks in this form, and carbon will get positive charge and X will get negative charge. So X minus is formed and C plus is formed. This C plus is known as carbocation. So once this carbocation is formed, this step is slow step, rate determining step, because in any reaction the slowest step is rate determining step. Why this step is slow? Because it depends on stability of this carbocation. If this carbocation is stable, then this alkyl halide easily breaks into this. If this is stable, then it will be easily formed. If this is not stable, it will not form. So this step is rate determining step, and this one is step 1, and this is step 2. And when carbocation is formed, nucleophile attacks on this carbocation. Now there is two possibility. Nucleophile either can attack from front or it can attack from back side. There is two chances. It can attack from front or it can attack from back side. If it attacks from front, this molecule will be formed, and if it attacks from back side, this molecule will be formed, nucleophile. Okay, so here first we see the geometry of this molecule. This is alkyl halide. So here 4 bonds are formed, 1, 2, 3 and 4. So its hybridization is, if 4 bonds are there, then hybridization is sp3.